The definite integral is a fundamental tool in calculus, allowing us to determine the area under a curve over a given interval. In fact, this concept is understood as the limit of a sum, known as Riemann sums, which approximates the area under the curve by dividing the area into smaller intervals and summing the areas of the rectangles generated by those intervals. As the number of divisions increases, the approximation of the integral becomes more precise, and in the limit, the exact value of the definite integral is obtained. Therefore, this is essential for calculating areas, lengths, volumes, and other concepts in various fields of science and engineering. Through this concept, important properties of the definite integral are introduced, such as its linearity and additivity over intervals. Furthermore, immediate integrals are highlighted. These are integrals that can be calculated directly using standard rules, without the need for complex methods. Among the most important results are the mean value theorem of calculus, which states that there exists at least one point in the interval where the slope of the function is equal to the average of the slopes over the entire interval, and the fundamental theorem of calculus, which links the derivative with the integral, providing an efficient process for calculating integrals. By applying these theorems and methods, practical problems such as calculating areas of plane regions, arc lengths of curves, and volumes of solids can be solved by integrating appropriate functions.